Hello class, we're about to start section 3.2, graphing linear equations using intercepts. The x-intercept of a line is a point where the line crosses the x-axis. The y-coordinate of an x-intercept is 0. So they want us to sketch an example. So first we must designate our x-axis, which is the horizontal line, and our y-axis, which is the vertical line. Now we look here at this graph. Wherever this graph hits the x-axis, that is its x-intercept. It hits the x-axis here. So that means that y is 0, and whatever the x value is, that is what your x is equal to. Now we go down here to the y-intercept. The y-intercept of a line is a point where the line crosses the y-axis. The x-coordinate of a y-intercept is 0. Again, we look at this line and see where it hits the y-axis. It hits the y-axis down here. So this is where x is 0 at, and it hits the y-axis, so this is the y-intercept. Now we scroll down. It says use a graph to identify intercepts. Okay, I took the liberty of already filling in this section here because there was a lot of jumping when I wrote on this section. So let's take a look here. We have example 1. Find the x-intercept of the line. Okay, so we go right here to this line and we see where it hits the x-axis. It hits the x-axis at 2. So we could write this as an ordered pair, which would be the x value 2, and then we know y is 0. Or we could write it as just x-intercept equals 2. Just depends on the problem and the question. But both of these are acceptable answers. Okay, B. It says find the y-intercept of the line. Now the y-intercept is where the line hits the y-axis. It hits the y-axis at -1. So our ordered pair, x is 0 and y is -1. So our ordered pair is 0, -1. Or we could write the y-intercept is equal to -1. Now we come to C. It says find y when x is 6. So we will go here where x is 6, and then we will go where the line hits the y. Well, not the y-axis, but where the line crosses x at 6. So it crosses here at 6, and y is 2. So your answer here is y is 2. Now it says D, find x when y is -4. So we will go down here to -4, where y is -4, and go over to where the line hits where y is -4. And if we notice here to find x, we will go up. X is -6. So our answer here is x is -6. Now, we scroll on. It says here, does the graph of a linear equation in two variables, a line, always have an x and y intercept? Now, the answer is no. A line does not necessarily have to have an x and y intercept. Like if you take this line here, the only thing we have here is an x-intercept. This line never crosses y. And right here, we only have a y-intercept, and it never hits the x-axis. So those are two examples of why that answer is no. Okay, objective 2. It says graphing a linear equation in two variables using intercepts. Find the x-intercept of the graph of 2x plus 5y equals 20. So we know in order to find the x-intercept, that is when y is 0. So we go through and substitute for y and then solve for x. So we would substitute in 0 for y. So we have 2x plus 5 times 0 equals 20. Now we know 5 times 0 is 0, plus 2x is 2x. So we have 2x is equal to 20. Now we would divide each side by 2. And x is equal to 10. Now it says here, find the x-intercept. Now in most problems, because you're getting to upper level maths, typically they want you to list your intercepts as ordered pairs. So we will list this intercept as 10, 0, because our x is 10 and our y is 0, and this is the x-intercept. Okay, now we come down here to example 3. It says find the y-intercept of the graph of 2x plus 5y equals 20. Now we know with the y-intercept, that's when x is 0. So we're going to put in 0 for x. And then we will solve for y. 2 times 0 is 0, plus 5y is 5y. And we have 5y is equal to 20. We divide each side by 5. 5 divided by 5 is 1 times y is y. And 20 divided by 5 is 4. So your y-intercept is 4, so we will write that as an ordered pair. X would be 0, and your y would be 4. And that is your final answer. Now it says an equation of the form ax plus by equals c, where a, b, and c are integers, is said to be in standard form. It is usually quickest to graph a line in this form by finding its intercepts. So now it says use intercepts to graph ax plus by equals c. First we find the x-intercept, let y equal 0 and solve for x. Then we find the y-intercept, let x equal 0 and solve for y. Then we find a checkpoint, a third order pair solution. And then 4, graph the equation by drawing a line through the 3 points. Now this is what's going to happen. We will find the x-intercept, the y-intercept, and then we will find just one more ordered pair that works with this equation. And then we will graph it. Now we come down here to example 4. It says use intercepts to graph 6x minus 9y equals 18. So first let's find the x-intercept. That's when y is 0. So we have 6x minus 9 times 0 is equal to 18. So it'd be 6x minus 0, which is 6x, and it equals 18. We divide each side by 6, and x is equal to 3. Now, that's our first ordered pair here would be 3, 0. That would be the first thing that we would graph, which would be 3, 0. Now next, we have to find the y-intercept. So we would take the same equation, but this time we're going to let x equal 0. So we have 6 times 0 minus 9y equals 18. 6 times 0 is 0 minus 9y is a negative 9y equals 18. We divide each side by negative 9, and y is equal to negative 2. So our ordered pair here would be 0, negative 2. Okay, now we need to find a third value. Now this is what we could do. We already used, we have 6x minus 9y is equal to 18. We use 3 for x and negative 2 for y. So why don't we do this? Why don't we use 6 for x? So we will have 6 times 6 minus 9y equals 18. 6 times 6 is 36 minus 9y equals 18. We can subtract 36 on both sides, and we will have negative 9y is equal to negative 18. We divide each side by negative 9, and y will equal to 2. So now this ordered pair would be 6 for x and 2 for y. Now we need to graph this. So first thing we would do, let's graph 3, 0. So we'll go here to the origin, and we will go to the 3 and put a point here on the 3, 0. Now we go here to the next point, 0, negative 2. We go here to the origin, and we just go 2 down. And now we have a point on 0, negative 2. Now our last point is 6, 2. So we'll go to the origin, we will go 6 on the x-axis, and then we will go 2 up. So this would be 6, 2. Now we need to graph this. Okay, to graph this, I'm going to have to insert an object here because it'll make it a lot easier. So what I would do is, at these points here, I would try and make sure that this line here goes through all of the points. So let me get this line back here. Okay, now we have our graph. Okay, now this is the answer to example 4. We graphed it and we have our 3 points. Okay, now Now we need to scroll on down. And now we go to example 5. It tells us the graph x plus 2y is equal to 0. Now we could use the same formula we used above here. Let's find the x and y intercepts first. So with the x-intercept, y is 0. So it'd be x is equal to 0. So our ordered pair here would be 0, 0. Now we do the same thing for y. This time x would be 0. 0 plus 2y is 2y equals 0. Divide each side by 2 and y is equal to 0. Now this is going to have the same ordered pair of 0, 0. Now this is a little mistake here, but this is 0, 0. So we know we're going to need at least 2 more points, because the only point we have here that we could graph so far is 0, 0. So let's try this. Since this 2 times y will give us some form of even number, even though it may be negative or positive, let's make x a number that is even. So let's make x 4. So we would take the same equation, we'll substitute in 4 for x. So 4 plus 2y is equal to 0. We can subtract 4 on both sides, and we have 2y is equal to negative 4. We will divide each side by 2, and y is negative 2. So one of our ordered pairs is 4, negative 2. Now we could go back here. Let's make x, well, let's do y here. Let's make y 3. So we could say x plus 2 times 3 is equal to 0. So it'll be x plus 6 equals 0. We subtract 6 on both sides, and x is equal to negative 6. So our ordered pair, x is negative 6 and y is 3. So now we graph this. We already graphed the 0, 0. Now we come to 4, negative 2. We go 4 on the x-axis, and we go 2 up here. So that's 4. Oh, actually, no. That's incorrect. We were supposed to do 4, negative 2 in our graph, 4, 2. Okay, now, with 4, negative 2, we go 4 on the x-axis, and then we go down 2. Next, we have negative 6, 3. So now we go to the left 6, which is negative 6, and then we go up 3, which is here. Now we need to graph this line. So we go to insert, get our shape, get our line here. We can start here from the back. I need to adjust this line just a little bit, just slightly, as if it'll let me. Won't let me adjust it all the way, but yes, this is supposed to go through all of the points to form a straight line. So now we're done with that problem. Now we come down here to example 6. It says find 3 solutions for each of the given equations, then sketch a graph of the equation. Now listen, whenever you have x and no y in the equation, this means that no matter what y is equal to, x will always be negative 2. So we could do it like this. We could just say 1, negative 2. Oh, actually, no. X will always be negative 2, not y. So let's do that again. Okay, x is negative 2. Let's make y 2. X is still negative 2 and y can be 1. And then x would be negative 2 and y is 0. These are 3 points that we could graph, because remember, x is always negative 2. So we had negative 2, 2. We have negative 2, 1. And we also have negative 2, 0. Now we draw a quick little line here. Now this line will go straight up and down. Be a quick vertical line. Let me get this in here. Okay, so you would do a vertical line.